So
Yes.
basically, a router is a device which we basically use in the layer 3. What's the layer name? It's network layer. Now we will come down, we will come to the layer 2, where we are going to use switches. Switches are basically, there are different switches. Layer 3 switches are also there, which are basically switches, but they work as a router in the layer 3 also. But we are going to talk about layer 2 switching. So data link layer is the second layer of OSI model, where the devices that we use are like hubs and switches. So mostly, and nowadays a network uses switches for their configuration within a local area network. So layer 2 switching. We are going to discuss layer 2 switching, or you can say data link layer switching. SWITCHING, switching. So what is it? What's layer 2 switching, or you can say data link layer switching? Basically, we're going to go through the overview first, and quickly we will start the practicals without wasting our time. But you need to understand what switching is and what layer 2 switching is, or you can say data layer switching. So it's a process of using devices MAC addresses to decide where to forward frames. Switches and bridges, BRIDGES, bridges are used for layer. So bridge is also a layer 2 device, so layer 2 switching. They break up one large collision domain into multiple smaller ones. Now, if you try to understand what's the basic difference between a routing and switching. If we talk about routing, basically in routing, the packets are used and the packets are forwarded from one router to another. But how the packets are forwarded? Based on the IP address. So router is going to decide the path based on IP address, right? Which is basically stored in the routing table of a router. But here in switching, we do not have that process. Basically, the process happens over here in switching based on MAC address. So in switching, it's local area network. Within a local area network, if a computer wants to communicate with another computer with the same network within the same local area network, basically switches are used at that time, and switches are not going to help us to forward the data or forward the packets. You cannot say packets to switching. We are using frames here. So we can send the frames, or switches are basically going to decide the frames or decide the path of the frame based on MAC address. So this is the basic difference between routing and switching. In routing, we are using IP addresses, and in switching, we are using MAC addresses. Based on that, switch is going to forward a frame which comes from host A to host B. Or so suppose that we have a switch here. How do you understand it? It's a switch, and we have different types of devices here. 1, 2, 3, and 4. So what's the process? Suppose that they all are configured with IP addresses, and when you connect them to the switch, a switch will send requests to the computers. I told you before also, it's going to send an ARP request to the computers to get the MAC address, so that in switch, the MAC address will be stored. So In switch, we are storing MAC address, and that MAC address is called as, or when we store MAC addresses of all the computers which are within the local area network, the address table is called as, like we have routing table in routers, here also we have the table that's called as MAC table, or you can say MAC address table, or sometimes people call it CAM table. Okay, so all the MAC addresses will be stored here. Suppose that now this particular device wants to communicate with this device, when this will open command prompt and ping the IP address. So what will happen, it will just forward the frame to the switch. Switch will check whether this MAC address is available in my MAC table or not. If it's available, it will check on what port it's available. It will forward the port on that particular frame. I mean, that particular device. That's how the process of switch is going to happen. Understood?
Yes.
So simply you need to remember only two things. First thing is MAC address is used in switching to forward the frames. And over here in routing, we use to forward the packets, but in switching, we use to forward the frames. These are the two devices, and switch is going to decide the path based on MAC table, based on MAC address table, which it stores it in the flash memory of the switch. Okay, so that's what switching is, and that's the process how. And the switches are going to help us to break a very big collision domain, like for example 252 IP address into multiple ones, so that the processing will be more faster, which we're going to learn later on. And in the typical LAN, all hosts are connected to one central device. In the past, the device was usually a hub. Before, when there was nothing like a switch in the layer 2, there was a device called hub. But hubs had many problems. You can say hubs. As I've told you in my Network Plus also, what hub is and what are the disadvantages of hubs. So like, for example, such as not being aware of the traffic that passes through them. They're not aware of the traffic which is going to pass through them. They just use to, receive the packet and just broadcast it. And they're not going to take or monitor the things, or they cannot monitor the traffic. That's why this is the main disadvantage of hubs. So they're creating one collision domain at straw. So these are the problems of hubs, which I've already, told you in my previous classes of CompTIA and Network Plus. But here, why switch came into existence to overcome the problems of hubs. Then bridges were created. They were better than hubs because they created multiple collision domains, but they had limited number of ports. That was the main important thing. Now, after hubs, bridges were created. They were creating different multiple domains, but the problem was there were limited number of ports. So finally, to overcome the problem of bridges, switches were created and are still widely used today, because in switches we have nearly about hundreds of ports to which we can, or to whom we can connect all our hosts. Whether it depends which type of switch you are going to purchase. If you wanted to have 110 port switch from Cisco, or there are 100 port, there are different vendors also, they used to give you like 10 port switch, or 20 port switch, 30 port switch, or 50 port switch. But Cisco is having their own standards. There can be like, I hardly know, maybe it's 109 port switch they used to have, where you can connect 109 devices. And in a switch, each port on a switch is a separate collision domain, so no packet collisions should occur. So when a switch is going to have a port, when you add a device, each device is going to have a separate collision domain. So there is no way that a switch can broadcast. So simply a host can send the packet or frame, and it will be received. A switch will take the decision and forward the frame to the destination. That's how switch is going to work very smoothly. And switches, or you can say layer 2 switches, are faster than routers because they do not take up time looking at the network layer header information. What they do is instead they look at the frame's hardware address to decide what to do with the frame, to forward, flood, or to drop it. So there are two things: to forward, or to flood, or to drop it. So The major advantages. So now advantages of L2 switching. SWITCHING. So first advantage is fast hardware based BRID GING using ASICS chips. Second is wire speed. Third is low latency. And fourth is low cost. You know about the difference between hubs and switches, right? I'm not going to repeat that because I have taught you, right?
Yes.
Okay. And even I told you how a switch is going to perform the things, but still how there are more things that you need to understand how switch works, the technical terms, how switch work. So how switch is going to work? When you talk about a computer, or you can say every computer is going to have one network card, right? Or you can say every network card has a unique identifier called MAC. What's the full form of MAC? Media Access Control, right? Which is MAC address. So this address is used for LANs for communication between devices on the same network segment. So simply you need to remember that MAC addresses are used within the same local area network in order to communicate within the network, within the same local area network, whether there are 200 devices, 300 devices, or 252 devices. We are using MAC addresses, and the devices that we are using for that is switch. So now the question is, those devices who want to communicate with each other, devices that want to communicate need to know each other MAC addresses, each other's MAC addresses before sending out packets. Suppose that this device wants to communicate with this and they want to communicate each other. These all want to communicate with each other. For that, what they should know the MAC addresses of each other. So how they can do that? Switches also use MAC addresses to make accurate forwarding or filtering decisions. When a switch receives frame, it associates the media, or you can say MAC address, control address of the sending device with the port on which it was received. So the table that stores such association is called as I've told you, we will have MAC address. The table that stores such, or that stores MAC address associations is called as MAC address table. So this address or this table is stored in the volatile memory. So associations are erased when you reboot your switch, or you can say when you turn off your switch by mistake. So whenever you turn off your switch, those associations are erased at the same time because they remain in the memory, the volatile memory. So volatile memory is the memory where when you turn it off, when the power gets shut down to that memory, when there is no power to that memory, whatever is stored in the memory, it's going to be deleted. Now, switches usually perform three functions in a local area network. First is address learning. Second is forward or filter decision. And loop avoidance. These are the three things, or these are the three functions that switches are basically performing. So address learning, what do you mean by address learning? Yes, anybody?
Means
What do you mean by address?
learning the addresses of the devices that's connected to it.
Yeah, exactly. So address learning, switches learn MAC addresses by examining the source MAC address of each received frame. So address learning is simply that learning the addresses from the devices to whom the switch, of the devices which are connected to the switch, it's going to learn the addresses. So switches learn MAC addresses by determining the source MAC address of each received frame. So when you ping a network, or when you ping a particular IP address, you're getting a MAC address with it. So it's going to learn that address and then store that address in the MAC table. And the next time onwards, it's going to just forward the frames based on that particular association. You understanding?
Yes.
Next thing is forward. Now forward is when switch is done with address learning, it has to take the decisions to forward the frames, right? So at this time, what forward or filter decision is, it's switch decides whether to forward or filter a frame based on destination MAC address. So on this, switch is going to simply forward the packet based on destination MAC address. And then in the third one, loop, switches use a protocol STP to prevent network loops while still permitting redundancy. So STP is spanning T protocol, which it's using basically to avoid looping in switches. So these are the three main important functions that switches are basically providing us. So first is address learning. They're learning the address from other devices. Then they're taking the decisions whether to forward or filter them based on destination MAC address. And then loop avoidance, which is STP. A protocol is used, which is STP, which we are going to learn in our future classes. Okay?
Okay.
So an example of a real-time example. Suppose we have a network of, I can draw a switch here. A topology will be drawn here. This is host C, host A, host B, and host C. This is, suppose that MAC of it is anything. Here is one more MAC address. Suppose that, let's say that host A wants to communicate with the host B for the first time. Please try to understand. Let's say host A wants to communicate with the host B for the first time. So host A knows the IP address of host B. That's the first thing. Suppose, and let's say that host A knows the IP address of host B. But since this is the first time the two hosts communicate, the hardware MAC address are not known, right? This particular device doesn't know the MAC address of this, and this host A doesn't know the MAC address of B. They know just A, the host A knows only the IP address. Because it's the first time, they have not known the MAC address, the hardware address of the A device, or you can say host A or host B. So host A uses the ARP process to find out MAC addresses of host B. So as I've told you, ARP is address resolution protocol, which is always going to help us to get the MAC address from any device, right?
Yes.
So host A will use the process of ARP, request and reply, ARP request, and this host B will reply with the MAC address. So the switch forwards the, when host A wants to get the MAC address of B, first of all, it sends a request to switch, which is S here. So ARP request will be sent to switch here, and switch will forward the ARP request out to all the ports. At that time, ARP is a broadcast, except the port A, which it's received from. You understanding? So
Yes.
host B will receive the ARP request and respond with the MAC address. When host B will receive the request, host B will respond. That means ARP reply will be sent by host B with the MAC address. So host B also learns the MAC address of host A because host A sent its MAC address in the ARP request. Are you understanding? So when host A will send the ARP request, it will also send the MAC address of the host A, and B will also learn. So by sending an ARP request from host A to B, both the devices will be able to learn their MAC addresses. You understand?
Yes.
So host C is here. Host C receives the ARP request but does not respond since the IP address listed in the request is not its own. So host C will not reply. It will not respond because the IP address listed in the request is not the host C's IP address. So communication will happen between only, but ARP request will be broadcasted. Now, based on IP address, B will reply back. Are you understanding?
Yes.
Yeah, that's how ARP process is going to happen, and then how basically host A will get to know about the MAC address of host B, and how host B will be able to get MAC address of host A. Got it?
Yes.
So as mentioned above, as I've told you about, a switch learns MAC address or which MAC addresses are associated with which port by examining, or you can say a switch learns which MAC addresses they are associated with port by examining the source MAC addresses of each receiving frame. So because host B responded with the ARP reply that included its MAC address, the switch knows the MAC address of host B and stores the MAC address in its MAC address table. For host A, the switch knows its MAC address because ARP request that included it. So when you send a request, in the middle there is a switch. So it will store that MAC address also. When B will reply back, it will also store that MAC address. In the same way, when host A will, wants to communicate with the host C, in the same way, it will first of all send ARP request to host B, all right? And then it will just reply back, and host C will be able to, or communicate with A and get the MAC address of it, and host C MAC address will be also stored in MAC table of the switch. Got it?
Yes.
So by default, MAC address stay in the switch's MAC address table for 5 minutes. So if host A and host B decide to communicate inside the next 5 minutes, a new ARP process will not be necessary, all right? So every time it's not necessary that every time when you ping an ARP request will be sent. No. So when you first time, or when you first time about, that's why when you was pinging in a routing, when you was pinging from host to another host, it was just dropping the first particular packet, TLS packet. Second was coming while pinging. Basically, it was sending an ARP request first of all to get the MAC address. So that's why that packet was dropping out. So first time, every time, whenever you try to ping, so it's basically getting the MAC address first of the device, stores in the MAC address or switch, and then stores in its own particular MAC table, or in the switches, or in the devices. In a device also we have the MAC address table. You can use ARP-A on your computer. ARP-A, you can see ARP-A. These are all the IP addresses with the physical addresses, dynamic, static. So these are IP addresses. So ARP-A, these are all the IP addresses which are stored in your computer's MAC address table. Okay.
Okay.
And we have just 10 minutes time for this particular. So in switch, you can display the MAC address table of the switch using the command show MAC address space table. So this is the command with the help of which we can check the MAC address table of a switch. This is the command. All right. Every time if you have to check the MAC address table, by default, all the switch ports are under VLAN first, and that's a single domain. You understand?
Yes.
In ARP, as I've told you, there are two things, static and dynamic. When you go to ARP-A, there are two modes, dynamic and static. You can see these are dynamics, these are static. What do you mean by dynamic? Means that addresses were learned dynamically by using the source MAC address of the received frame. So these addresses are learned dynamically, and these are learned statically. You understand? So in here also we have static addresses and we have dynamic addresses or MAC addresses. Okay.
Yes.
Now, what do you mean by collision domain and broadcast domain? Any idea?
Collision is when two devices send messages at the same time.
Mm-hmm. Yep.
So collision domain is where, like in each switch, a switch in each port is a collision domain.
Mm-hmm.
But in a router, each port is broadcast domain.
Basically, what collision is? Collision is simply when two packets will collide each other, right?
Yes.
So a collision domain is the name simply which implies the part of network where packets, or you can say packet collisions can occur. So collision is a part of network where a packet collisions can occur. So a collision occurs when two devices send a packet at the same time on the shared network segment. So when a device host or host A will send a packet at the same time, and B will also send, and C will also send. So at that time they will collide each other, but it's not happening with the switches. I will tell you later on why. So that's collision. So the packets collide and both devices must send the packets. Again, this is happening, which reduces network efficiency. So collisions are often in a hub environment. In a switch environment, we do not have collisions, because in hub, when we send, suppose that now this is an example of a hub instead of the switch considered is it is a hub. So each port on a hub is the same collision domain. By contrast, each port on a bridge, a switch or router is a separate collision domain. So each port on this particular hub is in the same collision domain. But if you compare it with a bridge or with a switch or a router, every particular port is in a separate collision domain. That means they listen and forward the packets by their own. They have their own collision domain at the same time. So there will not be any collisions to occur, but when you use hub, they are in the same collision domain. So what happens in hub, when you send a packet, other particular devices have to wait. Otherwise, the collision will occur, and every time the devices have to send their packets again and again. You understanding? But
Yes.
in switches, it doesn't work because switches are in single collision domain. All right, so you need to remember that each port on a hub is in the same collision domain, while each port on a bridge, a switch, or a router is in a separate collision domain. You understand? So that's why there is no chance of collisions to occur in between the packets. Now, what's broadcast domain?
It's when a device sends a broadcast, where will the packets reach?
Yep, exactly. So a broadcast is basically the domain in which a broadcast is forwarded. A broadcast domain contains all devices that can reach each other at the data link layer, like OSI model using broadcast. So all ports on a hub or a switch are by default in the same broadcast domain. So all ports on a switch are by default on the same BROA cast domain. So on a switch, by default, if a switch is having 20 ports, 30 ports, they are in the same broadcast domain, not in the collision domain. They are in the single separate collision domain, but they are in the same broadcast domains. You understand? So all ports on a router in the different broadcast domains and routers do not forward broadcasts from one broadcast domain to another, but switches in the picture. So all ports on a switch are by default on the same broadcast domain. So switches always broadcast, not always. The first time when you connect the devices, at that time switches broadcast, but after some time they used to only multicast the things. You understand?
Yes.
So not always switches broadcast, but sometimes when they need to get the MAC addresses of the devices they use to broadcast, they used to send ARP, requests. So ARP request is a broadcast which they will send out to the all ports so that they will get the MAC addresses and store them in the MAC address table of a switch. Are you understanding?
Yes.
So that's it. Then what is CSMA-CD? CSMA-CD is not used nowadays in hubs. Like I told you, collision domain. Now, if it's a hub and this particular, host A wants to send a packet to host B, and now at the same time, host C wants to send a packet on the host B. They want to pick. No, now this, what is CSMA-CD? CSMA-CD is carrier sense, or you can say CSMA CD, the full form of it is carrier sense multiple access with collision detection. So where there is, if the packets are going to collide each other, this particular technology, this particular protocol or tool is going to help you to decide when to send the packets on a shared network segment, and it's going to detect collisions if they occur. For example, in a hub network, two devices can send the packets at the same time. This can cause a collision, but CSMA-CD enables devices to sense the wire to ensure that other devices currently transmitting packets. So if you have a hub and CSMA-CD is enabled here, so when this host A is sending the packets, there is sense. CSMA-CD is going to enable the sense in the wires to ensure that no other device is currently transmitting packets. So that's why it will help host A to transmit the packets. So that is CSMA-CD. So that simply you can say that CSMA-CD enables devices to sense the wire to ensure that no other device is currently transmitting the packets. So it's by default enabled, or you can enable it in hubs. But in switches, we don't need it. If two devices sense that wire or sense the wire is clear and send packets at the same time, a collision can occur. And if the collision occur, packets have to resend after a random period of time. That's the thing. And since switches are now commonly used in networks instead of hubs, and CSMA CD is not really used anymore. But you just need to remember, if you're using hubs over there, in order to get rid of the collision in between the packets, we are using CSMA CD. So what is CSMA CD? It's going to help us to sense the wire in order to transmit the packets and make sure